Work and energy. Work is force times displacement, in which force and displacement must be parallel. If they are not parallel, you need to resolve either the force or the displacement into x and y to make it parallel. The general formula that your book gives you is force times displacement cosine theta, but sometimes it will be a sine theta. Just make them parallel. Conservation of energy is the total energy before and the total energy after has to remain constant. The types of energy that you will encounter in class are kinetic energy, energy of motion, spring energy, energy due to spring, and gravitational potential energy due to height. So whatever energy you start with, the energy has to end up with the same, constant. The other way you could write this is, remember, energy is the ability to do work. We could rewrite this as work is equal to change in kinetic energy, which is the energy work theorem or work kinetic energy theorem. This is also true. And last thing, it is scalar. We don't account for direction. The only time we account for direction is to make them parallel. And remember, there is no kinematics on this test. Let's look at example 66 from your packet. A sled is pulled with a force of 225 newtons along a rope above the horizon. If the sled moves a distance of 65.3 meters, how much work does Mike do? So the first thing I want to do is draw my picture. So if I draw my picture, I have a force. This force is 225 newtons above the horizon. That's 35 degrees. And it moves a distance of 65.3 meters. So in order to do work, we know work is equal to force times displacement. We know it is going to the right. The force that is given is at an angle. So what I need to do is find the force that is parallel to this displacement. And if you notice, that is Fx. Since it is next to the theta, that's going to be F cosine theta. So if I plug this in, this is force times cosine theta times my displacement. So this is going to be 225 newtons cosine 35 degrees, and displacement is 65.3 meters. And if you plug this in, you should get 12,035 joules, or 1.2 times 10 to the 4th joules. If you notice in this situation, if I did FD cosine theta, it was the same. But sometimes it will be sine theta. So this is example 71 in your packet. Peter slides by exerting a 225 force parallel to a ramp. So I know this is kind of like an inclined plane. So I'm going to draw my picture. Since it's parallel to my inclined plane, this is my force that is exerted by Pete. The crate moves at a constant speed. There's a friction in the opposite direction with 0.28. How much work is done to raise a vertical distance of 1.15 meters by Pete? The ramp angle is 30 degrees. So we want to know the work done by Pete. The distance that is given is 1.15 meters. Since Pete is going parallel to the ramp, the force is at this angle, the displacement is vertical. So I need to resolve one of the components. I'm going to still do work is equal to force times distance. if I use 225 newtons, I need to make my 1.15 meters into my hypotenuse. To do that, the angle that I gave you on your paper is 30 degrees. This is 1.15 meters. To make it parallel, I need to find the hypotenuse. If you notice, 1.15 meter is opposite, so I know this is going to be sine theta. Sine theta is opposite over hypotenuse. So that's going to be sine 30, 1.15 meters divided by hypotenuse. So I need to multiply both sides by hypotenuse. The hypotenuse cancels out on the right side. And so I need to divide by sine 30 on both sides. The sine 30s cancel out. And then I need to divide this side by sine 30. So if I clean up my math, it becomes hypotenuse is 1.15 meters divided by sine 30, which equals 2.3 meters. So I need to multiply this by 2.3 meters. And if I multiply these two numbers together, you get approximately 517.5 joules. So if you notice here, I use sine theta. I didn't use cosine theta. You just need to make the force and displacement parallel. You could resolve the displacement or you could resolve the force. They just need to be parallel. We're going to change this problem up a little bit, and we're going to say the crate has a mass of 50 kilograms. And what we're going to do is we're going to calculate the work done by gravity. And then the work done by friction. So to do the work done by gravity, I need to continue my free body diagram. So work done by gravity is due to weight. So if I write my work is equal to force times displacement, this becomes Fg times the displacement. Weight is equal to what? M times G, mass times gravity, times the displacement. We know the mass is 50 kilograms. We know gravity is 9.8 meters per second squared. And the displacement is 1.15 meters. If you notice, I did not have to do sine or cosine. Why? Weight is parallel to the displacement. This is Fg, and the displacement was parallel. So now all I have to do is multiply these. So this becomes 563.5 joules. Now we're going to find the work due to friction. In order to do that, we need to complete the free body diagram. You know there's a normal force perpendicular to the ramp. Now I'm going to take my normal, I'm going to extend it back to resolve my weight because my weight is at an angle. Remember, on a ramp, this is my x and perpendicular to that is my y. So this becomes Fgx, since it's opposite, Fg sine theta, and then this is Fgy. So that's next to the theta, because remember this is my theta, this is going to be Fg cosine theta. So we know friction is equal to mu n, and what is n equal to? So if I write my Fy equation, n is going up, this is opposed by Fgy. Remember, we are not moving or accelerating in the x or the y direction, so ma is equal to 0. So n is equal to Fgy, which is Fg mg cosine theta. And what is weight equal to? Mass times gravity. So it becomes mg cosine theta. So this becomes mu mg cosine theta. So if I plug in for work due to friction, this is going to be work is equal to friction times displacement. So this is going to be mu mg cosine theta. So now I need to find my displacement. Since the force is along the ramp, friction, the height is given as 1.1 meters, but it's vertical. So I need to find the displacement parallel to the friction. Since 1.15 is opposite, we know this is going to be sine theta, opposite of 1.15 meters. And we're looking for the hypotenuse because that is the distance that, or displacement, that's going to be parallel to the friction. So if I solve for this, this is sine 30, 1.15 meters, hypotenuse. So hypotenuse becomes 2.3 meters. If you do not understand how I solve the math, the beginning of this problem shows you how to find this hypotenuse. So I know my displacement. So now I'm going to plug in. So this is going to be 0.28. We said the mass was 50 kilograms. This is 9.8 meters per second square. My angle is 30 degrees. So I'm going to erase some of this. So this becomes cosine 30 degrees. My displacement is 2.3 meters. And if I multiply this, you should get approximately 273.28 joules. Is also conservation of energy. It has a steady force of 1400. Is connected to a sled that is at rest, so V initial is 0. We're looking for the distance, how much distance to bring the sled to a speed of, so that's my final. And then my mass is given as 100 kilograms. Again, if you don't know where to start, identify the variables. So if I notice this is a work changing kinetic energy theorem, so this is KE final minus KE initial. My initial cancels out because my V initial is 0. I'm going to plug in for force times distance, 1/2 mass velocity final squared. Divide both sides by F to isolate that. So D becomes mv final squared over, I'm going to bring the 2 down here, so 2F. So if I plug this in, this is 100 kilograms times 0.70 meters per second squared divided by 2 times my force, which is 1400 newtons. So if I plug this in, this becomes 0.0175 meters. So if you are stuck and you don't know where to start, identify the variables. The only formula we have with these variables is the work kinetic energy theorem.